LeetCode problem number 25, reverse nodes in K group. This video contains its optimal approach discussion and motivate viewers to code it themselves. Let's see the approach. So the problem is very much similar to the previous problem that we have seen. LeetCode problem number 24. In this problem problem number 25, we will be given a linked list. Let's name them to understand it through example: A, B, C, D, E, F, G. Along with the head of the list, we will be given a value k. K is the size of a group for which we need to reverse the linked list. Let's suppose for a value k is equals to 2, what we need to return is BA, DC, FEG. This will be the order of our linked list if k is equals to 2. If k is equals to 3, then we need to return C, B, A, F, E, D, G. This will become the order. How I'm calculating it? I'm calculating it this way. Like if k is equals to 2, I will swap it, I will swap it, I will swap it, and it is less than k, so I will not do any operation there. See, this is for k is equals to 2. If the k is equals to 3, then the group size become this much, and we will reverse them in group. So to do this, what we need to do is, let's break down the whole problem in a single problem. When we know the size of the group for k is equals to 3, let's suppose this, what exactly do we need to perform? We need to just reverse this connection. Earlier A was pointing to B, now B should point to A, C should point to A, C should point to B, and we don't know where should A point unless we have reversed this part also. So we will reverse it. E will point to D, F will point to E, and where D should be pointing, we don't know. We will check out later part. So here G is the only node. It was earlier pointing to null, but here we see that it is not completing the size of pair. The k is equals to 2. So we will simply make D points to G. So this way we can see that G was pointed by D, G was pointed by D, then D was pointed by E, and E was pointed by F. Then what we need to return is, we need to return A. A must be then pointing to F. This way. We will do this recursively. In a single call, what we will do is we will reverse it. The tricky part comes when the last part of the linked list is not completing our linked list, our group size k. Then what we need to do? It's a very interesting approach. If for this k is not satisfying, it's for this I is equals to 1, which means the size of this group is only 1, which is less than k. What we need to do is we need to perform the operation, reverse the linked list for k is equals to this much, the size of the remaining group size. For if it was of 2 size, what we were doing is, let's make it clear. In a single call, what we are doing is we are reversing it for each completion of group size. But when the group size is not getting completed, but we have performed a reverse operation, we will again reverse it to make it the way it was earlier. And from each call, we will reversing the tail of the linked list that we have been working on. Then its tail will be transferred to what previous call, and its tail will be given as our result head. The code part for this solution is mentioned in the description. Do check it out.